negative numbers, and we talked about multiplication of positive and negative numbers. Finding the quotient is the division of positive and negative numbers. They follow the same rules that multiplication of positive and negative numbers do. Okay? If your signs are the same, what's my answer? Positive. So a positive over a positive or a negative over a negative. That's going to be a positive answer. If my signs are different, if I have one positive and one negative, what's my answer? Negative. Okay? And that's just something that you kind of want to have close to you. So, let's do these. The first one, I've got negative 16 divided by negative 4. Negative 16 divided by negative 4. That is a negative divided by a negative. So my answer is going to be, my answer is 4, and it is positive 4. Okay, it's positive because I have a negative divided by a negative. Now I have 28 divided by negative 7. 28 divided by negative 7. What's my answer to that one? It is negative 4. The reason that it is negative 4 is because I have one positive and one negative. Okay? Okay. The next one is a negative divided by a positive. So my answer is going to be negative. You have probably been doing this type of problem on a calculator for a while. So we need to remind ourselves how to do decimals. So I am going to divide 3.6 by 4. Now we've already decided that my answer is negative because I've got one negative and one positive. So I am going to put the 3.6 inside my division box. Okay? The 3.6 goes inside and the 4 goes outside. When I am dividing with decimals, I am going to take that decimal and I am going to move it straight up. Okay? I'm moving that decimal straight up. Now I'm going to do division. 4 will not go into 3, so I put my 0 there. 4 will go into 36 9 times. So my answer to this is 0, negative 0 and 9 tenths. Or you could say negative 9 tenths. So that's just a little review on the decimals. There's not a ton of computation with decimals, but it does come up. You need to know how to add and subtract and do simple division like this. Okay, so we have to remind us of those things. And again, you don't want to do your homework with a calculator. You don't want to do your homework with a calculator. You want to do your homework the way that you're going to have to do the test. Yes, ma'am?
But like when we're doing our homework, can we check?
Yes,
afterwards?
that would be fine. And also the answers are in the back of your book. And I will be posting solutions to homework also. But yes, if you want to check to make sure you're right, you can. Just know that you won't have that for a test. But yes, that's completely fine. Now, this problem right here is 0 divided by 7/8. I actually think that could also be 0 over 7 divided by 8. I'm not sure that the book is super clear on what this problem is. I do think what it wanted it to be was 0 divided by 7/8. Okay? I think that was the intention. Was 0 divided by 7/8. I will make sure it's very clear what you're dividing by on your quiz or your test. Now, when I do division of fractions, we reviewed that on Wednesday. It is keep my first number, make my division multiplication, and then I flip it, or I make it its reciprocal. So I have 0 over 1 times 8 over 7. So the answer to that is 0 over 7 or just 0. Okay? Now, what if I had something divided by 0? What is that? It is not 0. It is not 1. It is undefined. Okay? Anything divided by 0 is undefined. That is going to be very important when we start doing our linear stuff. That is when that's going to be the most important, is when we do our linear stuff. Okay? Okay. Now, can I go off this screen? Okay. Now what we're going to look at is we are going to look at order of operations. Now, order of operations is one of those things that causes me to have to stay off Facebook when there's major conflict on math problems, is because we do not remember order of operations correctly, okay? Sometimes on Facebook, I think the last one even made the news. They called the professor from Georgia Tech to get it settled. How many of you remember PEMDAS? PEMDAS, okay. PEMDAS is not order of operations, okay? PEMDAS is not order of operations. PEMDAS is an acronym to help us remember order of operations, okay? So it's a trick. It's one of those tricks that we use to remember order of operations. The problem is we remember it incorrectly. Whenever you were taught order of operations back 5th, 6th grade, I am certain that you were taught it correctly. The problem is, as adults, we do not remember it correctly. This is the order of operations. Grouping symbols, exponents, multiplication, and division from left to right. And it's that right there that students forget. Because in PEMDAS, what does it suggest? Multiplication and then division. That's what happens with PEMDAS. It suggests that you do multiplication, then you do division. And you don't. You have to do multiplication and division at the same time. So you're adults. It's very hard to unlearn something that we learned a very long time ago that we have believed to be foundational in all of our skills. So what you have to do is, if you have got to put multiplication and division together. Students tend to not make the same mistake with addition and subtraction. It's that multiplication and division that really, really gives students headaches. So multiplication and division has got to be done from left to right at the same time, in the same step. If you come to division first, you do division first. Okay? The same is true for addition and subtraction. But typically by this stage in your academics, you think of subtraction as addition anyway. You're thinking of that negative sign belonging to the number that follows that minus sign. And so typically students don't have as much issue with the addition and subtraction. It's that multiplication and division. That's where students make mistakes. So this is what it is. You've got to do multiplication and division from left to right. Okay? Okay. Now, we're going to get started with a fraction just because we love fractions. Love them. So, do you see that negative 2 1/3? That negative 2 1/3. That is a mixed number. The first thing that I want to do is I want to address that mixed number. I want to turn that mixed number into an improper fraction. It's just going to be easier for us to deal with. So it's negative, so I'm going to keep it negative. Then I am going to take my 3 and I am going to multiply it times the 2. What's 3 times 2? 6. Then I am going to add 1 to it. 7. So I have negative 7 over 3. Okay? Now, I want you to look at all of the parentheses that I have in this problem. Okay? I have a parentheses here, here, and here. In order of operations says that I've got to simplify grouping symbols first. However, is there anything inside of those individual parentheses that can be simplified? Now, I'm not talking about things here, like multiplying. I'm talking about inside. Is there anything that I can do with negative 1/3? Is there anything I can do with negative 5 or negative 2/3? There's not. And so I leave those alone. Because when I'm talking about grouping symbols, I'm talking about the stuff inside. the stuff inside the grouping symbols. And so there's nothing inside of any of those that can be simplified. So do I have any exponents? I have no exponents. So I'm not raising anything to any power. Okay? So now I'm dealing with my multiplication and division from left to right. Okay? So I'm just going to rewrite my negative 7 over 3. This is 4 over 1 times negative 2/3. What's 4 times negative 2? Good. 1 times 3. Good. I always deal with that negative sign in my numerator. I always deal with it in my numerator. Now, you can deal with this minus and negative right now if you want to, or we can deal with it in the next step. If we want to leave it as subtraction, that's fine, because that we can deal with it during the addition and subtraction step. If you saw this negative and negative from the very beginning and turned that into a plus, that would be okay too, and I'll show you why in just a second. So I'm going to leave my minus as a minus, and I'm going to have negative 5 over 1. Negative 5 times negative 1 is positive 5. 1 times 3 is 3. Okay? Now I can change this to plus negative 5 over 3 if I want to. Sometimes students like to leave it like that. Okay? Okay. Now I've got negative 7 over 3 plus negative 8 over 3 plus negative 5 over 3. What's negative 7, negative 8, and negative 5? You're close. 20. So it's negative 20 over 3. Now, that is an improper fraction. Negative 20 over 3 is an improper fraction. Is it a simplified improper fraction? Yes, it is. Okay, there's no number that goes into negative 20 and 3. Okay? Now, I'm going to erase this right here, and I want to show you what would happen if I went ahead and changed that at the beginning. We're going to get exactly the same answer. So if you want to deal with this right here from the very beginning, you can. It's completely fine. So I know that this is negative 7 over 3. And then this is going to be 4 over 1 times negative 2 over 3. Then I have plus 5 times negative 1 over 3. So I went ahead and dealt with that double negative from the beginning. I didn't do it during the addition and subtraction. And that's okay. Okay? So then I'm left with negative 7 over 3, negative 8 over 3, and here I end up with negative 5 over 3. So I still got the same thing doing it that way, dealing with that negative, that minus and negative from the beginning. Okay? Okay. Let's do some more. This is one where we're going to deal with our division first. We have to deal with our division first. So here I've got a negative 5 in parentheses, another negative 5 in parentheses, and a 3 in parentheses. Okay? Can anything inside the parentheses be simplified? No, there's nothing inside the parentheses that can be simplified, so I am going to leave that alone. I'm going to leave that alone. Nothing can be simplified. Okay? Now what I'm going to do is I am going to deal with all, and I also don't have any exponents. Okay? So I'm going to deal with my third step, which is multiplication and division in order from left to right. So I have to do this first because I come to it first. Then I skip my addition because that's not what step I'm on. I do my multiplication and I do this multiplication. Could I go ahead and deal with that minus minus? I could. Okay, and I think I am. I'm going to go ahead and make that plus right here. So, negative 24 divided by 4 is negative 6. 8 times negative 5 is negative 40. 5 times 3 is positive 15. Okay? Negative 6 and negative 40 is negative 46. So my answer here is negative 31. Okay, can I go to the next screen? This one, we have multiple grouping symbols. We have multiple grouping symbols happening here. We have our first grouping symbol that we're going to have to deal with is our 6 minus 7. Our 6 minus 7. Then the next grouping symbol that we're going to have to deal with is this bracket right here. Okay? We have to deal with that first. So you always have to go to the innermost grouping symbol first. And for this one, it's the parentheses. So I've got negative 7.3 minus 2, negative 4.6. What is 6 minus 7? Good. Okay. Now I'm going to deal with this right here. Before I start dealing with anything outside the brackets, I've got to deal with everything inside the brackets. So now I've got negative 7.3 minus 2. What is negative 4.6 times negative 1? Good. Okay. Now I've got negative 7.3 minus, but remember that's plus negative 2. So I'm actually taking this negative 2 and I'm multiplying it times 4.6. So again, we're going to have to go over here and we're going to have to review our decimal skills. So I have 4.6 times negative 2. Okay? Now I'm going to go ahead and deal with the negative because my answer is negative. Okay? I don't need to worry about dealing with the negative anymore. My answer is negative because it's a negative times a positive. Now I need to review how to multiply with decimals. So I have 2 times 6 is 12. 2 times 4 is 8. Plus 1 is... Okay. My answer is not 92 or negative 92. How many decimal spaces did I have up here? 1. That's how many decimal spaces I've got to have in my answer. Okay? So you can think of this as negative 7.3 minus 9.2 or negative 7.3 plus negative 9.2. Okay? Either one is fine. When we add decimals, we have to line up those decimals and just bring it straight down. Okay? So then my answer here is negative 16 and 5/10. Okay. Did anyone look at this problem and think to themselves, I need to distribute negative 4.6 to 6 and to negative 7. Did anybody look at that and say, okay, that's on the outside of a parentheses. I need to distribute it. Did anybody think about that? Okay, that's good. Okay, and that's fine. A lot of students in algebra think, oh, I've got to distribute that. And I'm telling you, if you did distribute it, you're fine. You would have gotten exactly the same answer. The reason that you don't have to distribute this is because inside this parentheses, 6 minus 7, that can be simplified. If it couldn't be simplified, then we would have to distribute. We typically distribute when we have something like x plus 3 on the inside. Now, it would not have been wrong if you had distributed that negative 4.6. You would have gotten the same answer. But this is typically what we look like when we're distributing. And that wasn't what we had here. If you can simplify what's in parentheses, you want to go ahead and do that. Okay? Can I move to the next screen? Okay. Now we are moving into simplifying algebraic expressions. Algebraic expressions. Now, the difference between a numerical expression and an algebraic expression is that algebraic expressions have variables. Algebraic expressions have variables. Okay, so that's the difference between what we were doing and what we're doing now. Okay, so here we do have to use the distributive property. And the reason that we have to use the distributive property is because we can't simplify x plus 2 because we don't know what x is. If we were told what x was, we could, but we aren't told. So we are simplifying this algebraic expression. So we are going to do 4 times x, then we are going to do 4 times 2. So I have 4x plus 8. Then I have 3x plus 18. So I have distributed here. Now, we have got to address what's called like terms. Like terms. Now, 4x and 3x are like terms, as are 8 and 18. Negative 4y and positive 8y are like terms. Any constant, that's a number without a variable, 2 constants are also like terms. The one that students forget is when I have this right here. Okay? A like term is the same variable raised to the same exponent. Same variable raised to the same exponent. And I'm going to run out of room right there. That's exponent. Same variable raised to the same exponent. So 3x squared plus 4x squared, they are like terms because x is raised to the second power on both of them. Okay. Now, going back to our problem here, we have 4x and 3x. What is 4x plus 3x? 7x. Here I have 8 and 18. What is that? 26. Can I combine 7x and 26? No, because they are unlike terms. Okay? Now I'm going to give you 1 minute to do the next one. Okay? And I want you to be careful here. Think about that one. Savannah? You need to be sure to sign the roll. Rakisha? Robert? Tyler Martin? And Marissa. Be sure you sign the roll. Okay. What are we distributing in our first one? Good. We're distributing -5. Okay, and we are distributing -5 to both of these. So I've got -5 times y and -5 times 3. So I have -5y, then what? -15. It's negative because we are distributing a -5 and to a +3. So that's -15. Now, here I've got a -2. I'm giving the -2 to the y, and I'm giving a -2 to the -8. So that is -2y plus 16. So be careful. Be careful. Okay? Now, can I combine like terms here? Yes. -5y and -2y gives me -7y. -15 and +16 gives me +1. Okay? 1 minute to do this one. This one's got bigger numbers but no negatives. Okay, here we're dealing with both an x and a y, but we don't have any negative numbers. So that's beneficial not to have the negatives. So I'm distributing the 3 to the 2x. So that's going to give me 6x plus 15y. I have 4 times 3x. That's 12x. 4 times 2y is 8y. Okay, now I've got 6x and 12x. It's 18x. 15y and 8y. It's 23y. Okay? Can I go to the next screen? So, here we were simplifying algebraic expressions, and before that we were doing computation with numbers. We didn't really have any variables in there. Here I have 3x minus 4y. 3x minus 4y. And I am told x equals 2 and y equals -3. X equals 2 and y equals -3. Okay? So I am going to rewrite this expression with a 2 wherever there's an x and a -3 wherever there's a y. Okay? So I have 3 times 2 minus 4 times -3. So I've got 3 times 2 is 6. -4 times -3 is +12. And so I'm left with 18. Okay. The next one is a little bit more challenging. The next one is a little bit more challenging. I have x squared minus 2xy plus y squared. X squared minus 2xy plus y squared. My x is negative 2 and my y is negative 5. So I am plugging negative numbers in for my variables. The appropriate way to write this is negative 2 inside parentheses, because that is my value for x, squared, minus 2 times negative 2 times negative 5 plus negative 5 squared. Now, what happens is students will often write negative 2 squared, and then they will put negative 2 squared in their calculator. And when they do that, they get negative 4, because they are only telling their calculator to square the 2. They're not telling their calculator to square the negative and the 2. This is one of the reasons we don't allow calculators in this class, is so that you can really wrap your mind around this concept right here, and also other concepts. You really need to write it as negative 2 squared, because the negative and the 2 are being squared. So that is positive 4. So I have negative 2 squared. Okay. Then I have, and actually I'm going to leave all of this because I am doing the order of operations on the exponent level. I'm not multiplying yet. I'm only doing the exponent. Then I've got negative 5 squared, and it's the same thing. We're squaring a negative, and anytime you square a negative, you get a positive. Okay? So my negative 2 squared and my negative 5 squared, they both became positive numbers. Now I'm going to deal with all that's being multiplied together, and I'm going to deal with it the order that I come to it. So I'm going to leave my 4. Then I've got negative 2 times negative 2, which is positive 4. Positive 4 times negative 5. What's that? Negative 20. Okay? Now, students can do this in various orders. It doesn't really matter which order you do this in. I typically add my 2 positive numbers together. What are my 2 positive numbers? Good. So then I have 29 plus negative 20. So my final answer here is 9. But some students also like to just go in order. So 4 plus negative 20 is negative 16. So if I add those two together, I get negative 16. Negative 16 plus 25 is 9. So either of those is fine. Yes, question?
You know, perfect how we write negative 20. We want to put plus negative 20 parentheses, or I can do it like subtract.
Are you asking if it's okay to write it like this?
Yeah.
That is 100% correct. And it's fine to write it like that. It's just a matter of a preference of how you like it. But it is okay to write it like that right there. Okay. Now, I know that not everybody has your book. If you do have your book, if you turn to page 31 to 32 in your book, that gives you a whole list of words that help you translate verbal words into algebraic phrases. There's a whole bunch of them. Now, on your homework, your last couple of problems for this section include translating phrases into something algebraic. It isn't, you're not solving them. Sometimes students get confused because they think it's a word problem and they're solving it, but you're not. You don't have to solve them. You're just translating them. We'll start solving them a little bit later. And so if you get stuck on these, you can go back and look on pages 31 and 32. There's a whole bunch of phrases there. We're going to do 2 or 3 right now. And what we're doing is we are answering the question. And students really get hung up on that because they don't feel like it's an actual answer. Okay? So Sonia can keyboard 65 words per minute. How many words will she keyboard in M minutes? Okay, so I'm going to have something in terms of M. Now think about, if she can type 65 words per minute, and I asked you, how many words can she type in 3 minutes, what would you do? 65 times 3. Okay? If I said, how many words can she type in 5 minutes, what would you do? 65 times 5. 10 minutes. 65 times 10. So what I'm asking is, how many can she type in M minutes? It is 65 times M. That's what it is. Okay? So you're not finding an answer. What you're doing is you're translating this. Yes?
Branching off what you said like a couple minutes ago when you said you can write it however you want, is it fine if I just leave it at 65M?
Yes, 65M is completely fine. Like this right here? Yes, that's completely fine. Completely fine. Okay? Let's try another one. Okay. Russ has N nickels and D dimes. Express this amount of money in cents. Russ has N nickels and D dimes. How much is a nickel worth? 5 cents. Now, writing it as 5 cents hurts my heart because we don't write it like that, do we? How do we write it? Not 0.5. 0.05. Okay? Okay. I prefer the 0.05 just because we don't function in cents. We just don't. If you write it as 5 cents, you're correct because that's what it's saying. Okay? How do I do a dime?
0.10.
Good. Okay, if you wanted to do it in cents, what would you do? Okay, now, this is my dollar sign right here, and this is my cent sign. What if I wrote 0.05 cents? What does 0.05 cents mean?
Like less than a penny.
Yes, a lot less than a penny. That's what this means. This is wrong right here. Okay? This is okay, and this is okay. But don't combine the dollar decimal with the cent sign. Okay? So there's actually 2 different ways that we could write this. He has N nickels. We don't know how many nickels he has, but we know how much a nickel is. And that's 5 cents. So 5 cents times N. And he has D dimes. And dimes are worth 10 cents. That's one way that we could write it because that's in cents. I prefer this because we operate in dollars. Okay? So I want you to know that either of these is correct. Okay? And again, you're not trying to find out how much money he has. You're writing an expression to illustrate how much money he has. Okay? One more. The length of a rectangle is L centimeters and the width is W centimeters. Express the perimeter of the rectangle. Now, I always draw a rectangle. Okay? That's the first thing that I do in this situation is I draw a rectangle because it helps my brain to think about what I'm dealing with. Okay? So I have the length of a rectangle is L, and the width is W. Express the perimeter of the rectangle. Okay? What is this length up here? What is this right here? L or W? L. So what's my other side? Okay. So perimeter is 2L plus 2W. If you wrote W plus L plus W plus L, you're just adding up the sides to that. That's okay also. Okay? But once you simplified it, you'd still get 2L plus 2W. So either of those is okay. Okay, what is happening